Hello there. We start off with the second class of the chapter three-dimensional geometry. Now, in this class, we are going to discuss all about planes, and in details, we are going to talk about the equation of plane, then the intercept form of plane, that is another form of equation of plane, then angle between two planes, and then distance between a plane and distance from a point to a plane. Fine. Now, to start off with equation of plane. Now, if I know the direction ratio of the normals to a plane, and if that be a, b, and c, then equation of a plane is given by ax plus by plus cz plus d equals to 0. Then in the vector form, let us just give that direction ratio a name. So let that be n vector, that is ai plus bj plus ck. Then the equation is given by r vector dot n vector plus d equals to 0, where r vector is the current vector. Again, this is called a point form. Now, if I know the direction ratio of the normal, that is a, b, and c, and if I know if the plane is passing through a point x1, y1, z1, then the equation of the plane is given by a into x minus x1 plus b into y minus y1 plus c into z minus z1 equals to 0. The same thing in the vector form. If a vector is the point which through which the plane is passing, and n vector is the direction ratio of the normal, then the equation of the plane is given by r vector minus a vector dot n vector equals to 0. Then again, if I know the direction cosines of the normal to the plane, that is lm and n, and small p, that is the perpendicular distance from the origin to the plane, then the equation of the plane is given by lx plus my plus nz equals to p. So the same thing if you want to write in vector form, that becomes r vector dot n cap. N cap means it is the unit vector in the direction of the normal, and p is, as always, the perpendicular distance from the origin. Now let us take few examples and understand. Now the first question is, find the direction cosines of the normal to the plane 2x plus 3y minus z minus 7 equals to 0. Now looking at the equation of a plane, you can first find the direction ratios. From there you can find the direction cosines. So looking at the equation of the plane, I can directly say that the direction ratios are 2, 3, and minus 1. So how to find the direction cosine from direction ratio? You just divide by the magnitude of it. So if you just divide it by the magnitude, that is under root 2 square plus 3 square plus minus 1 square, that gives you root over of 14. And so the direction cosines are 2 by root 14, 3 by root 14, and minus 1 by root 14. Find the Cartesian equation of the plane r dot 5i plus 7j minus 11k equals to 14. Now, if you all remember how the Cartesian equation happens, that is, if the equation of the plane in the Cartesian, that is ax plus by plus cz equals to d, let me take the d on the other side, then that in the vector form is going to be something like this. So this x, y, z comes here, this a, b, and c comes here. Fine. So therefore, just following the analogy, you can find the equation of the plane in the Cartesian form. So let us see. So this is what given, and from here r is x, y, z and your 5, 7 and 11, these are the n vector. So therefore from there I can say that the Cartesian equation is 5x plus 7y minus 11z equals to 14. Similar question the other way. 3x plus 7y minus 6z equals to 5. This is the question given. You have to find the vector equation of the plane. So without wasting any time, directly you can write that the vector equation of the plane is r vector dot 3i plus 7j minus 6k equals to 5. Moving on to the next problem. Find the equation of the plane passing through the point 4 minus 1, 2 and perpendicular to the line x minus 1 by 2, y minus 2 by 3 and z minus 3 by 4. So remember this, that any plane can be identified by the direction of the normal. Normal means perpendicular. Now this line is said to be perpendicular to the plane. So therefore, if the line is perpendicular to the plane, that means the line must be parallel to the normal. And if I know that the line is parallel to the normal, that means the direction ratio of this line is basically the direction ratio of the normal. So therefore, the direction ratio of the normal is as given in the question, that is 2, 3 and 4. So I have one information, that is the direction ratio of the normal. Now it is given that it is passing through the point 4 minus 1 and 2. So therefore, I also know a point through which the plane is passing. So now all I need to do is construct the equation. So given the 1-point form, I can write the equation of the plane something like this. And then just doing the calculation, the equation of the plane is 2x plus 3y plus 4z is equals to 13. Fine. Number 5. Show that the line this is parallel to the plane x plus 5y plus z equals to 7. So first let us find all the direction ratios. So direction ratio of the line is this 1, minus 1 and 4. Direction ratio of the normal to the plane is 1, 5 and 1. Now to show that the line and the plane are parallel, all I need to do is to show that the line and the normal to the plane, these two are perpendicular. Now how to show that two lines are perpendicular? We need to show their dot product of the direction ratios are 0. So let me check if the dot product is coming out to be 0. So if I do the dot product, that is 1 into 1, 5 into minus 1 and 4 into 1, that exactly comes to be 0. So therefore from there I can directly say that the line and the plane, they are parallel. Find the vector equation of the plane which is at a distance of 6 by root 29 units from the origin, and its normal vector from the origin is 2i minus 3j plus 4k. Also find its Cartesian equation. So let us start. Now what are the things given? I am given the normal to the plane, that is 2i minus 3j plus 4k, and also I am given the distance from the origin. So from the normal, let me just try to find out the unit vector towards the normal. So once I know the unit vector and I am given the perpendicular distance from the origin, so therefore I know that unit vector means I know the direction cosines. So given through that formula, the equation of the plane is r vector dot n cap equals to p, or r vector dot this vector 2i minus 3j plus 4k by root 29 equals to 6 by root 29. So I can just cancel out that root 29, and therefore r vector dot 2i minus 3j plus 4k is equals to 6. Number 7. Find the equation of the plane passing through the point 1 minus 2 1 and perpendicular to the line joining the points A 3 2 1 and B 1 4 2. So let us find out first the direction ratio of the line joining the points A and B. Now, once I know the direction ratio of the line joining the points A and B and says that it is perpendicular to the line, so therefore it must be parallel to the normal. So therefore this is actually the direction ratio of the normal. And also it is told that it is passing through this point 1 minus 2 and 1. So we have to do just the same thing by writing the equation of the plane in that 1 point form. And this so is your equation. Fine. Let us move to number 8. Find the point where the line x minus 1 by 2 equals to y minus 2 by minus 3 equals to z plus 3 by 4 meets the plane 2x plus 4y minus z equals to 1. So I have to just find the point of intersection of this line and the plane. How to do that? So let me consider that the line x minus 1 by 2 equals to y minus 2 by minus 3 and z plus 3 by 4 equals to some t. So from there I can write x is equals to 1 plus 2t, y is equals to 2 minus 3t, and z equals to 4t minus 3. You have already done this in the previous class when we were working with lines. So the same thing. And now let us put this into the equation of the plane. So if I put it into the equation of the plane, calculate, I get the value of t, that is equals to 1. So let us put that back into the equation, that is x equals to 1 plus 2t and y equals to 2 minus 3t and z equals to 4t minus 3, and therefore the point of intersection is 3 minus 1 and 1. Number 9. Find the distance of the point 2, 12, 5 from the point of intersection of the line given this and the plane this. So first we need to find out the point of intersection, and then we need to find the distance. So there are two things to do. So let me just go on quickly running you through the way of finding point of intersection, which is something we did in the last problem itself. So first I need to find out the general coordinates of the points on the line and then put that into the equation of the plane to satisfy, and from there to find the value of lambda. So the value of lambda becomes 4. Now I have done it in the Cartesian way, the vector way. If you are not accustomed with the vector way, you can always do it in the Cartesian way. There is no hard and fast rule that if the question is given in vector form, you have to do it all in vector form. You can do it in Cartesian form, but ensure that the final answer you write has to be in vector form, and the same applies for Cartesian as well. So once I have found the value of lambda, from there I can find the point of intersection, and this is the point of intersection, that is 14, 12 and 10. Now all I need to do, I need to find the distance. So the distance is, by the calculations, 14 minus 2 whole square, 12 minus 12 whole square and 10 minus 5 whole square, that gives me 12 square plus 5 square, and the answer is 13 units. Number 10. Find the image of the point having position vector this in the plane this. So this is a very pathological question of this chapter to find the image of a point considering the plane as the mirror. So all I need to do first find the foot of the perpendicular and then use the midpoint theorem to find the image. So what are the things given? The direction ratio of the normal, which I know, and then I need to find what is the equation of the perpendicular line. So let me just draw it and show it to you. What is the situation given? So let us consider that this is a plane and there is a point somewhere here. Now I need to find, say this is the perpendicular, and I need to find this point. So this is your foot of the perpendicular. Now I know the direction ratio of the normal. So what is the direction ratio of the normal? It is given 3, -1 and 4, right? This is the direction ratio given. Okay. Now once I know this direction ratio, understand that direction ratio is basically what we call as slope in 2 dimension. That is basically what direction ratio or direction cosine is in case of 3 dimension. So once I know the slope, or to be exact the direction ratio, and also I know the point through which the line is passing, then I can definitely find the equation of the line. So that is exactly how we have done it. Once we know the equation of the line, now I will just find the point of intersection of the line and the plane. That will give me the foot of the perpendicular. Fine. So that's exactly what we are trying to do here. So we know the direction ratio of the normal, we know the point through which it is passing. So from there I can write that this is the equation of the perpendicular. Now let us just find out the point of intersection of this line and this plane. So once we find that, we get the foot of the perpendicular. So once again, let me first write the general form of the equation and then put it into the equation of the plane and then calculate. After doing the calculation, the value of t becomes -12, and let us put it back into the general form. So I get the foot of the perpendicular as 3/2 -3/2 and -1. So how I am getting this? Putting this t here. If I put it back here, I get the value of the coordinate as this. Fine. So now I know that this is the foot of the perpendicular and this is the point for whose image I am trying to find out. Now I need to find out the image. So obviously this foot of the perpendicular is the midpoint of the line joining the image and the object. So therefore, following that, the value of the image is 0, -1, -3 if I write in coordinate form. If in vector form, then it is -j -3k. Now let us come to the intercept form of the line. Intercept form of the plane. Now for any plane, the intercept form is given by x by p plus y by q plus z by r equals to 1. This is pretty much exactly the same thing for straight line as well in 2 dimension, the way you would have written. And this p, q, r, these are the intercepts made in the x, y and z axis. And now if there are 2 planes, that is a1x plus b1y plus c1z, I should have put one z here, I missed that z, plus d1 equals to 0, and a2x plus b2y plus c2z plus d2 equals to 0, then the equation of the plane passing through the line of intersection of these 2 planes are given by a1x plus b1y plus c1z plus d1 plus lambda times a2x plus b2y plus c2z plus d2 equals to 0. Right? The same thing that which you have done in case of lines in 2 dimension. Now let us take problems. Find the intercept made by the plane 2x plus y minus z equals to 5 on the coordinate axis. Very simple problem. Divide the whole equation by 5, and if you do so, we get x by 5 by 2 plus y by 5 and z by minus 5 equals to 1. So therefore the intercepts are 5 by 2, 5 and minus 5. Next one. Find the equation of the plane which passes through the point 3, 2, 0 and contains the line this. So here what we need to do, I am given a point through which the the plane is passing, and also it is told that it contains a line this. Now I don't know what is the point, right? I don't know the direction ratio of the normal to the plane. I know a point through which it is passing, and I am given that also a line which is in the plane. Now, if the plane contains the line, then it must contain all the points on it, right? Now, one of the points on the line, that is 3, 6, 4, which is pretty much visible in the equation itself. And also I know 3, 2, 0, that is another point on the line, right? So therefore, direction ratio of the line joining these 2 points is this, 0, 4 and 4. Fine. And direction ratio of the line which is given, that is 1, 5 and 4. Fine. Now, all I need to do, I need to find the direction ratio of the normal to the plane. So I have got two direction ratios of two different lines which are on the plane. Then how to find the direction ratio of the normal to the plane? Just take the cross product of it. Why? Because cross product always gives you a vector which is perpendicular to the plane containing the two vectors. So therefore, whatever the thing I am going to get, that is the direction ratio of the normal. Right? So once I have got the direction ratio of the normal, I know one of the points through which it is passing. Therefore, the equation of the plane is this: x minus y plus z equals to 1. Let me just give you a pictorial idea if it is hard for you to understand. This is the plane whose equation I don't know. There is a line on the plane. I don't know what line it is. I don't know through where it is passing, but definitely it is somewhere on the plane. And there is another point on the plane. I don't know where exactly it is located along with the line. How close or how far it is from the line, I don't have any idea. But I know that there are two things, one point and one line. Now, what I am trying to do, I am given the direction ratio of this line. I know, because from the equation of the line only I can find the direction ratio. Then let us consider any one of the point on the line, and then let me find out the direction ratio of the line joining these 2 points. So I get two different directions. So all I need to do, I need to find the normal. So what I do, I take the cross product. If I take the cross product, I get the equation of the normal. And once I get the equation of the normal, I have the point on the plane. So from there, I can find the equation of the plane. Fine. Next, find the equations of the planes that passes through the points this, this and this. So you are given 3 different points and you have to find the equation of the plane. Now, let me consider equation of plane in the intercept form, that is x by p plus y by q plus z by r equals to 1. Now these 3 points are on the plane, so therefore they must satisfy the equation. So therefore I get 3 different equations. These are the 3 different equations that we get. Now all I need to do, I need to solve these 3 equations simultaneously. Now I think we all know how to solve 3 variable equations simultaneously. You can make use of the matrix form as well. So after solving, I get the value of 1 by p as minus 3 by 2, 1 by q as 5 by 2, and 1 by r as 0. So therefore, the equation of the plane is minus 3 by 2x plus 5 by 2y plus 0 equals to plus 0 equals to 1. And now then you just go on manipulating. That gives you 3x minus 5y plus z. 3x minus 5y plus 2 equals to 0. Now you may ask me that isn't this equation of a line? Obviously this is not equation of a line given that z is 0. If I write this, then it becomes equation of a line. But if I don't write this, that z is 0, then it still remains equation of a plane. Clear? Next, find the equation of the plane passing through the intersection of the planes this and passing through the origin. So it is given that I have to find equation of a plane which is passing through the line of intersection of these two planes, and the plane also passes through origin. So first let me write the equation of the plane which is passing through the line of intersection. So it will be given something like this one plus lambda times this one, right? Now it is told that it passes through origin. So as it passes through origin, then I will have 9 plus 3 lambda is equals to 0, right? The whole thing becomes 0 on the left hand side. So lambda is equals to minus 1 by 3, and then let me just put it back. So therefore the equation of the plane is r vector dot I plus 10j minus 4k equals to 0. Right? So actually you are making use of all the different concepts of vector algebra here. There is nothing different that you are using. It's just that you have to remember and understand that what to apply where. Now let us come to angle between planes. Now if you are given the two planes, and if theta is the angle, then the angle between the planes is given by something like this, which is pretty clear to see. And if you are given a straight line and a plane, then the angle between the plane is given by this. Now how it comes? Obviously, let me just give you the picture here. Now if there are two planes, say these are the two planes, then another plane passing through it, just consider it like you have taken a book and opened a page and tilted a book in such a way that the two pages are making some angle to each other. So in that case, what happens? We can't directly find the angle between the two planes as if we are trying to find out the angle, but instead what we do, we try to find out the angle between the normals. Now whatever the angle made by the two planes will be the same angle made by the normals as well. So it is very hard to draw here. Now whatever the angle which the two normals make, I can find out by using the dot product formula, and that is exactly what I am using here. And in case of a plane and a line, so if I have a plane here and there is a line here, now let's say this is the normal to the plane and this is the line. Now if the angle made by the line and the plane, that is theta, then this angle is 90 minus theta. So therefore I am basically trying to find out cos of 90 minus theta. So that is only why I am getting this sign. Fine. So that's just the difference. Let us move to problem number 15. Find the angle between the plane this and this. So all I need to do, I need to first write the direction ratio of the two planes, then take the dot product, divide by their magnitude, and then take a mod, then whatever it comes, that is your cos theta, and so therefore the angle becomes cos inverse 4 by 21. Pretty simple, because we have done this in case of straight line as well. Next, find the equation of the plane through the point 1, 4 and minus 2 and parallel to the plane minus 2x plus y minus 3z equals to 7. Now we know if planes are parallel, then the equation of the plane will become, if ax plus by plus cz plus d equals to 0 is one of the equation, then definitely its parallel plane will become ax plus by plus cz plus some k equals to 0. So therefore direction, or we can just do it in a different way, that is whatever is the direction ratio of the plane, that is minus 2, 1 and minus 3, and I know the point 1, 4 and minus 2. So therefore just using that we can find the equation of the plane, that is minus 2x plus y minus 3z equals to 8. Fine. Next, number 17. Find the angle between the line r vector equals to this and the plane this. So first I need to find out what are the direction ratios of the plane and the line. I mean the normal to the plane and the line, and then use the sine inverse formula, and sine inverse this is going to become the angle between the two plane and the line. Next, find the equation of the plane through the point 1, 2, 3 and perpendicular to the line, perpendicular to the planes this and this. So it is given that whatever the plane I am going to find out, it is perpendicular to both the planes. So therefore let us first find out the direction ratio of these two planes and then take their cross product. Once I take the cross product, it gives me a vector which is perpendicular to both the vectors. So therefore this is the direction ratio of the plane which I am trying to find out, right? Now I know one of the points 1, 2, 3. So therefore equation of the plane becomes this. Always remember, whenever you are trying to find out anything perpendicular to two vectors, then always take their cross product. Next, distance of a point from a plane. So basically the same idea which you have done in case of your straight line in 2 dimension, the same thing here. If x1, y1, z1 is the point which is outside the plane, and ax plus by plus cz plus d equals to 0 is the plane, then therefore the distance from that point to the plane will be given by ax1 plus by1 plus cz1 plus d by root over of a square plus b square plus c square. The same thing is given in the vector form as well. Now if there are two planes, if you are trying to find out the distance between the two planes, now remember you have the concept of skew lines, but you don't have the concept of skew planes, at least not in our dimension we have, because if I want to have two skew planes, then there has to be a 4th dimension, then only we can think of skew planes. So at least we don't have any 4th dimension in real world, so we don't know how to think of skew planes. So if there are two parallel planes, at least that's the only thing we can think of. If there are two parallel planes, then to find the distance between the two parallel planes, all I can do is, if ax plus by plus cz plus d1 equals to 0 is one of the plane, and the same thing d2 is the other plane, then definitely I know it will be mod of d1 minus d2 by root over of a square plus b square plus c square mod closed. This is the distance between the two parallel planes. Fine. So this is all you have, and then let us move to the questions. Now I forgot to apply animation, so it just came all along. Find the distance of the point whose position vector is given this from the plane this. So just putting it this way, r vector times, or r vector dot I minus 2j plus 4k minus 9 equals to 0, and the point is given 2i plus j minus k. So therefore from there I can find the distance of the point following the formula, and this is the distance. Last one, if the distance of the point k3 minus 5 to the plane this is 3 units, then find the value of k. So just put it into the distance formula. That value is given to be 3. Calculate, you get the value of k. Now mod of k plus 7 equals to 9. Just remove the mod, then becomes plus minus. So therefore the value of k is 2 or minus 16. Now yes, I did it in a bit hurry, of course, which I am sorry for that, and also sorry for the late upload. Go through the problem one by one. These are the types of problem you have in your syllabus, and if you face any doubt, you can definitely get it cleared, and I hope you won't be having any difficulty in the understanding. Thank you.